So today we're going to talk about word problems and regressions. Go ahead and take a few moments, set up your notes, exponential functions, Unit 4A, Homework 7 with the appropriate date, and make sure you set up for questions or comments on the right-hand side of your paper before beginning. So Madison received $10,000 in gift money when she graduated from college. She deposits the money in an account that pays 5% compounded interest annually. Now, compound interest is interest or money paid by a bank to an account holder that is earned on both initial account funds or principal and previously earned interest. Now, it can be represented by this equation. A equals P times 1 plus R over the N to the NT power. Once again, some of these pieces are already familiar. A is going to be your Y, or your end amount. P is your initial startup, or what we see as A in our equation. R is the rate, which is your percentage. Keep in mind you need to turn into a decimal first. N is going to be the compound time, and we'll talk about compound time later. And T is for how long she's going to deposit it. So we're going to start with basics without using the equation first. We want to find the total amount of money in her account after the first year by multiplying the amount of Madison's deposit by the interest rate of 5%. So the amount of her deposit is $10,000. We're going to multiply it by 5%. Now keep in mind 5% as a decimal is 0.05. And so calculating that, we know she's going to earn $500 in interest for the first year. Now, if we take the interest and we add it to how much money she has, which is $10,000, how much money will she have total at the end of the first year? And that would be $10,500. Go ahead and take a moment, pause, copy before continuing on. So Madison wants to record the amount of money she will have in her account at the end of each year. So we're going to complete the table and round amounts to the nearest cent. Keep in mind she earned $500 in interest, and we got that by multiplying $10,000 by 5%. So we're going to take the amount she earned, $10,500, we're going to multiply it by the 5% again, and then the second year she's going to earn $525. So we're going to take that, add it to $10,500, and it gives me $11,025. We could take $11,025, multiply it by the 5%, and in the third year, she's going to earn $551.25 in interest. Now, when I look at the difference between these two, I have 1.05 as my difference. When I do 525 divided by 500, that ratio piece that we've been talking about in all our previous notes. And once again, we can see that it's also a different ratio of 1.05 between the next difference, which is 525 and 551 when I divide those two. If I were to complete the rest of the table, I'm going to notice my interest keeps going up. I'm earning more and more interest every year, but my ratio stays the same. So I can go ahead and create my equation for this. My initial amount, A, would be $10,000. So I start off my equation, f of x equals 10,000. Now I need to find my growth rate. And we know the growth rate is 1.05, and we know that it's growth because it's greater than 1. So how is the interest rate on Madison's account related to the constant growth factor? If I do 100%, which is what her amount is, $10,000, plus the 5%, which would be $500, so $10,000 plus 500 equals $10,500. That gives me 105%. And that simplifies to 1.05. So basically, it's just 100% plus the amount of her rate. Take a moment, pause, copy before continuing on. Now, Madison's future plans include purchasing a home. She estimates that she will need at least $20,000 for a down payment. So, using the previous information we did, determine the year in which Madison will have enough funds in her account for a down payment. Once again, we take our function that we created, f of x equals 10,000 times 1.05 to the x power. And we notice that in the 15th year, she will have $20,000. Now, if I were to identify a reasonable domain and range for this situation, we know that for domain, we're talking about time. And the one thing we always know about time is that it has to be greater than 0. And since we're talking about the 15th year, our domain has got to be greater than or equal to 0, but less than or equal to 15. Now, for range, we're talking about money. And what's the minimum amount that we're talking about? Well, we started with $10,000, but she needs $20,000. So our range will be between $10,000 and $20,000. So do the try it out. Take a moment, pause, copy, and then try 1, 2, and 3 based on the situation I'm giving you. The answers will be on the next page. So go ahead, check your answers. Once you're done checking your answers, anything you've had problems with, put a star by so we can discuss it when you come to class. Let's go ahead and move on to exponential regressions. So here I have a table of data. I have year, which seems to be going by decades or by tens, and then I have resident population. And so once I graph it, I can see it's got that curve that looks like it's going to be exponential. And it's pretty close. You can see there's a couple of points that don't quite fit. So I'm going to check the ratios of my resident population and see if I can find a common change that would represent my exponential function. So I notice they're not perfect, but they're pretty close to being the same. So what I'd like to try to do is an exponential regression to find my equation. Once again, an exponential regression, you're going to plug in your x values and your y values into stat. You'll use L1 for x and L1 for y. L2 for y. And we can already see it's got a curve, so we know we want to use exponential regression. So we'll go back into our stat menu again and choose an exponential regression to find my equation. Now, if you don't have a graphing calculator at home or don't want to use one online, just stop into my class anytime, or you can wait to come to class to try to find it. The equation that best matched this data would be f of x equals 170,377 times 1.645 to the x power. Once again, we see our rate of change, that exponential piece, is pretty close to the numbers I was coming up with. It would be almost an average of all of them. And then the 170,377 would represent my initial starting amount, which is pretty close to what I see on here. So this would be a very accurate gauge of this data. Take a moment, pause, copy, and be prepared to discuss when we come to class.